Right now, there are over 25,000 known asteroids that cross Earth's orbit. We call them near-Earth objects, and we're discovering about 3,000 new ones every year. Most are small, harmless, but some are planet killers. The question isn't if one will hit us. The question is when. And more importantly, can we actually stop it? 66 million years ago, an asteroid 10 kilometers wide hit Earth near Mexico. The impact released more energy than all nuclear weapons on the planet combined, times 1,000,000. Within seconds, everything within 1,000 kilometers vaporized. Within hours, the entire planet was burning. Within months, 75% of all species went extinct, including the dinosaurs. That was a mass extinction event. And it can happen again. Here's what terrifies scientists. We've only cataloged about 95% of asteroids larger than 1 kilometer. That last 5%? Unknown, untracked. Could be heading toward us right now. An asteroid smaller than 1 kilometer? We found maybe 40% of them. In 2013, an asteroid exploded over Chelyabinsk, Russia. It was only 20 meters wide. Nobody saw it coming. The explosion injured 1,500 people, shattered windows across the city. That was small. A planet killer is 500 times bigger.
And we might have zero warning. So can we stop one? Let's start with what doesn't work. Nuking it. Hollywood loves this solution. Send Bruce Willis with a nuclear bomb. Problem solved. Reality? That makes it worse. When you nuke an asteroid, you don't vaporize it. You break it into thousands of radioactive pieces, all still heading toward Earth. Now, instead of one impact, you have 1,000 impacts. Radioactive impacts. You didn't save the planet. You made extinction more creative. So, nuking is out. What about pushing it? This is where real science gets interesting. NASA's DART mission in 2022 proved we can actually move an asteroid. They crashed it into an asteroid called Dimorphos at 22,000 kilometers per hour. The impact changed the asteroid's orbit by 33 minutes.
That might not sound like much, but 33 minutes over millions of kilometers? That's the difference between hitting Earth and missing completely. This is called kinetic impact. Hit it hard enough, change its trajectory. No explosions, no debris, just physics. But here's the catch. This only works if we have years of warning. Decades, ideally. A tiny push years in advance changes arrival location by thousands of kilometers. But a huge push days before impact barely moves it. Time is everything. And that's the problem. Most dangerous asteroids come from the direction of the sun. We can't see them. The sun blinds our telescopes. They're invisible until they're almost here. The Chelyabinsk asteroid? Zero warning because it came from the sun's direction. If it had been 10 times bigger, we couldn't have done anything. So we're building better detection systems. Space telescopes that can see near the sun, AI tracking, early warning networks. But detection is only step one. Let's say we spot a planet killer, 10 kilometers wide, heading straight for us, 10 years away. What do we actually do? Option 1, kinetic impactor, the DART method. Launch multiple spacecraft, hit it repeatedly. This works best with decades of warning. It's proven technology. We've tested it. It's our most realistic option, but it requires precision. Hit it wrong, and you might break it into pieces. Multiple smaller asteroids. Harder to track. Option 2, gravity tractor. Park a spacecraft next to the asteroid. Not on it, just near it. The spacecraft's tiny gravity pulls on the asteroid. It's like trying to move a mountain by blowing on it, except it actually works. Given enough time, you need decades, maybe centuries for the largest asteroids. But no impact, no debris, no risk of breaking it apart. Option 3, laser ablation. Point powerful lasers at the asteroid. Vaporize surface material. The vaporization creates thrust. This is still theoretical. We haven't built lasers powerful enough, but the physics works.
Option 4, ion beam shepherd. Use ion beams to push the asteroid. More force than gravity, less than kinetic impact. Still theoretical, still requires massive engineering, still needs decades. Seeing the pattern? Every solution needs time. So here's the nightmare scenario. We detect an asteroid, 10 kilometers wide, coming from the sun's direction, 2 years away. We're dead. There's no solution, no technology, no miracle. We simply don't have enough time. 2 years isn't enough to build, launch, and execute any deflection mission. The asteroid hits. Civilization ends. This is the scenario that keeps planetary defense scientists awake at night. But here's where it gets interesting. NASA, ESA, and other agencies are taking this seriously now. The Planetary Defense Coordination Office exists. It's real. Its job is to find asteroids and figure out how to stop them. We have dedicated telescopes scanning the sky. The NEO surveyor will launch soon. It can see asteroids coming from the sun's direction. We're practicing deflection missions. DART was the first. More are planned. We're learning. The technology exists. The will exists. The question is, will we see it coming in time? There's an asteroid called Bennu, 500 meters wide. 1 in 2,700 chance it will hit Earth on September 21st, 2182. That might sound distant, but we're already planning for it. Mission concepts, deflection strategies, backup plans, because 150 years is enough time. We can stop Bennu if we start preparing now.
Then there's Apophis. We'll pass closer than our satellites in 2029. So close, you'll see it with naked eyes. We're studying it, tracking it, making sure it won't hit us on its next pass in 2036. So far, we're safe. This is the new reality. We know asteroids are out there. We know they can hit us, and we're finally doing something about it. But here's the honest truth. If a massive asteroid appeared tomorrow with less than 5 years warning, we're in trouble. Give us 10 years warning, we've got a shot. 20 years? Good odds. 50 years? We'll definitely stop it. But 2 years? We're probably extinct. That's not defeatism. That's honesty. So the real answer to can we stop an asteroid is it depends on how much time we have. We're the first generation with the technology to potentially save ourselves, but also possibly the last where it might be too late. The dinosaurs didn't have a space program. We do. That's our advantage. But we need to use it, fund it, prioritize it. 66 million years ago, the dinosaurs looked up and saw a new star getting brighter. They had no idea, no way to stop it. We're smarter. We're prepared. We have a chance, but only if we keep watching the sky. The question will be, did we prepare enough?